This is a Technicom podcast.
In this Ethics in Technology podcast series, we have determined that how the role of ethics should play out in research projects is not always clear. And we have seen this in all of our episodes. We also learned that the advancement of science as a whole relies on responsible research and sticking to ethics principles. It would seem then that the most effective approach is to tackle ethics training early on in the careers of the next generation of researchers. And I'm talking about at the university level here. But is this happening, and does it work? I'm Peter Ballant from Technicon, and today we speak with Elizabeth Oswald. She is a professor in the Department of Artificial Intelligence and Cybersecurity at the University of Klagenfurt in Austria. Her research projects deal with the concept of side-channel exploitations. She's here today to give us a glimpse into the academic side of ethics and research. Welcome, Elizabeth, and thanks for coming on today.
You're welcome. I'm looking forward to it.
While most of your focus is on the anatomy of side-channel attacks, there are, of course, ethical considerations in your work as a researcher and professor. First, tell us what a side-channel attack is.
Okay, let's perhaps start with what is a side channel in the first place. So in security, we are very conscientious about the way in which we argue about the security of a system. Thus, when we define a system and its security properties, then we are normally very, very explicit about all of the channels of information that we think an adversary has access to. And then we build a security model based on these known channels of information. So a side channel is an information channel that, for some reason, we didn't include in our security model. This could be because we weren't aware that this channel exists, or because we didn't realize that a known channel could be useful for an adversary, or simply because we might know that there is a channel and this contains useful information, but it's just too difficult to really reason about it. And perhaps we know that if we include this channel in our security model, the system would be recognized as insecure. An attack then uses this extra bit of information. And I'd like to give you a simple example to illustrate this, perhaps in a less abstract manner. So consider, for instance, a combination lock. The security model here of the lock would be, at least this is how they're advertised, that you need to know the secret combination in order to open the lock. So under the assumption that nobody knows the combination, a lock supposedly is secure. But if you just go online and search for how to break combination locks, then you will see lots of tutorials. And typically the way in which they work is that you're asked to listen very carefully to the sounds that a lock makes, or observe very carefully how much a lock moves after you kind of change one of the combination rings. And with this bit of extra information, so either the sound or the observable movement, you can then figure out which is the digit for each combination ring. And with this extra bit of information, you can actually open a lock in much, much less time and with much less effort than what it would be if you had to try out all possible combinations.
So that's a really great analogy, and I think that will bring the point home about what side channel attacks are, sort of coming in the side door, perhaps, if you will.
Yes.
So you are researching and teaching about these side channel attacks. Can you tell me what sort of ethical issues do you face in your day-to-day work?
Sure. So there are many aspects of ethics that really arise when you do research in the cybersecurity area. So depending on what kind of research you do, you might have humans involved, which immediately raise ethical concerns, or you might kind of study a specific type of engineering practice within a legal context, or you have very complex technical kind of questions that you answer using mathematics and computer science. So obviously any study that it would involve humans would always kind of lead to ethical concerns, and there are often processes set out by academic institutions of how you deal with them. But if you kind of go, so to speak, to the opposite end of the spectrum, if you just look at a thing, a product, or a device where some security claims have been made, then even there are ethical issues that crop up. For instance, you might want to look at the security of a concrete product, which means that if you actually find flaws, then you have to think very carefully about how you disclose them. And hence, the corresponding process is typically called responsible disclosure. If we though focus perhaps a little bit more on side channel attacks and how to deal with side channels, and then there's often a catch-22 that we run into in sort of our daily research practice, because if we want to demonstrate a new kind of attack vector, then often it would actually be possible to demonstrate this attack vector based on a sort of mock-up device. So maybe a simulation that we write that corresponds like real devices that we are aware of, and then we demonstrate it on that. But then typically during a peer review process, the argument would come, well, this is just a mock-up. This is not a real device. We want to see that your attack technique works on real devices.
Right.
And this is, of course, a problem, ethically speaking, because then we take a product that is on the market, we break it, and then, of course, you need to go through responsible disclosure. There is perhaps another kind of problem that arises, and this is called dual use. So typically in cryptography research, we try to create new algorithms or new implementations of algorithms that are stronger than existing ones. But in order to make something stronger, you really have to understand how to break things in the first place. So we kind of always look at attacks and countermeasures in a way simultaneously. And many discoveries that we make as researchers, which we make in good faith and which we make in order to kind of make things more secure, they will inevitably also help adversaries. And this kind of brings us into a dual use problem often.
And I guess this could be a real problem because most of the work that you do will be published. And when it's published, this means anyone can read it.
This is correct, yes. So especially when it comes to real life products, then the responsible disclosure process has to happen before the actual publication. That's very important.
Of course.
Now, in some of our previous episodes dealing with ethics in technology, we found out that ethics could sometimes be a moving target, especially perhaps in academia. And it's good that we're talking to you today to address this issue. And I'm curious, from your perspective, what is the best way to keep the topic of ethics integrated into some of the more practical topics that you tackle in the classroom?
You're right in the way that, in the sense that ethics is in itself actually a moving target, because ethics is nothing that you can define once and will sort of hold forever. Ethics depends on societal norms and values, which of course keep changing as societies change. And they are also different between different societies. So ethics is nothing that can ever be static. It always has to be negotiated for every project. It has to be renegotiated often during the project as understandings develop and change. And it's always very, very context specific. So at least when I talk about ethics, then I'm not so much talking about, knowing something about ethics or knowing some ethical guidelines or ethical standards. It's more about a skill that relates to asking, in a way, good questions. And this kind of process of asking questions whilst considering a research question or some project, there's another term for it that I often find a bit more useful, and this is called responsible engineering or responsible research and innovation. And this is indeed a process that you can, in a way, practice, and it becomes hence also, in a way, teachable. So it's something that we integrate in our teaching here in Klagenfurt, and it's something that then also, in a way, very naturally ties in with project work that I would be doing, so relating to my own funded project. And so it's really handy for me that I can have the opportunity to teach responsible engineering at university, because it gives me also the opportunity of practicing these skills and being reflective and considering potential unintended consequences of my own research.
Right. And it sounds like, since this topic of ethics is something that's always changing, the one constant is that it's always changing. And just being aware of this and maybe keeping up to speed with ethics on a much higher level and applying it to various situations might be the best approach.
Yeah.
This leads me to my next question, which is there some sort of organization which could guide researchers in cybersecurity with regard to implementing ethics measures during their work?
So when it comes to academia, for instance, often ethical guidelines are actually provided by publishers that kind of support cybersecurity research. So there are a few to name. So for instance, the USENIX organization traditionally publishes a lot of security and cybersecurity research. ACM and IEEE, these are all professional organizations that are international. And they have guidelines with regards to, for instance, responsible disclosure. They are also very clear when it comes to pieces of research that involve humans, that you have to go through whatever sort of approval process is normally in place at your university. It's much less clear exactly how to deal with ethics, I think, in a not in the academic context. So, for instance, I don't know how this would be dealt with in large companies, whether there are also ethics approval boards or things like that. But outside of then academic publishers, it's much less clear which organization you would actually turn to if you want some advice or some help in regards to ethical questions. I think there's actually quite a gap there. And there are also not so many guidelines available as such. In the context of AI, for instance, the European Union has published a set of guidelines which are very useful and very interesting to read. But when it comes to cybersecurity and ethics, there are some papers out there, but they're perhaps not concrete enough to really help. And as I said, the ethics is not so much about reading something and knowing about a guideline. It's actually much more a hands-on and applied skill, if you will. So you actually need an opportunity to practice it. And I don't think there are very many out there, outside of academia at least. So for me, the best opportunity to practice this myself really is in the context of teaching.
Well, thank you so much for this information that you shared with us today. It's interesting to see what happens on the side of ethics where students are involved and what you can pass down to them. So thanks for sharing this with us today, and we hope to talk to you again soon.
Thank you very much for hosting me.
This podcast has been brought to you by Technicon. For our complete series on ethics in technology, go to technicon.com/ethics.